So welcome everyone. Thanks for joining us on Friday. So today's topic is JMP's Text Explorer platform, which you can find under Analyze Text Explorer. Well, we'll talk about the platform and ins and outs of it. But before we get to that, I'm assuming at this point, most of you are JMP users. I saw on the poll, some of you are using version 17, older 18, 18 Pro. And so that means you're probably familiar that there are many tools built in JMP that are out there to help you to conduct statistical analysis or build predictive models. And also, and if you haven't found that or used it yet under add-ins, let me just move this out so I can see what's behind. Under add-ins, there's some deep learning tools built in under the Torch Deep Learning as well. But most of these tools require your data to have in some sort of numeric form so you can do analysis and build models with that. So today's topic is how to get text data into some sort of format that's available to use with most of the analysis tools built into JMP, whether you're fitting a model, looking at distributions, or building predictive models, or creating some sort of embeddings. Those are all require you to have numeric data. So that's what we're going to cover today. Take the text data into a usable form for numeric analysis. So before we get started, and Russ mentioned that most of you are new to the topic, there's some concepts that to get used to before we go into doing text analytics. And the main things to talk about here are words or phrases and sentences. Those are basically, in our common language, we talk about what's a word, what's a phrase. So word is one single word, phrase is made up of two or more words, and sentences are basically describing a thought from one period to the next period. And the corpus comes into play. What corpus is all the knowledge contained in that data file. So most of analysis are going to rely on the knowledge dependent on the data file that we are opening and working with. So that will be our corpus. And in terms of tokenizing, stemming, and stop words, those are basically what do we do with these words or phrases before we do analysis. And each of the word or phrase that we use, this will be clear when I open the platform and when I look at the terms and phrases. Each of those words or phrases are tokenized, meaning that we create a token that describes a word or a phrase, and each of those will be counted as a new variable in your data table. Stemming refers to when we're using words, are we going to treat, for example, swimming and swim and swimmer as the same word? Because the root of the word is, again, swim. So stemming refers to how do we want to treat the words as they're just looking at their root words, or we want to treat swimmer and swimming as different words on our different tokens in our analysis. And stop words refers to the type of words that are used to not necessarily change the meaning, but we use in everyday language. They're always existent in the text. And do we want to keep them as a part of our analysis or remove them? These words kind of like a and the and those type of words. And we'll talk about using them in our analysis in a second. And finally, putting it all together, document term matrix is that each of the rows in a JMP data table. Actually, let me just open up a data table here so we can look at that. And let me do just 1 second. So if I go to my JMP data table, so what we're referring to here is the whole data table is my corpus. And each of these rows referred as a document. So document term matrix is going to be, we're going to take each of these documents. From that, we're going to take out the terms, and then we're going to convert that into some numbers. And then this whole big data table is going to turn into a matrix. So we're going to save the results of the document term matrix, and then we can use that for our analysis. So that's a quick overview of like the concepts that you'll hear throughout the presentation, and I just wanted to clarify that in the beginning. So let's start with the platform. But before we go into that, during the platform, we'll talk about how to use the terms, find most common words, the context, and then what we can specify, how we can specify our own stop words, and use these patterns to identify topics, do some term selection, and sentiment analysis. These are all built in the text analytics platform. And what we're not going to cover is named entity recognition, summarization, natural language understanding, or large language models. So at this point, we're preparing our text for analysis, and what all these items are basically what you do with the text, not necessarily use the text for analysis. So we're not going to be covering these topics in this presentation. But if anybody is interested in doing this type of work, JMP, especially in JMP 18, we have built-in Python integration, and we can talk about that in detail as well. So let's talk about what the platform looks like. What we'll do is we'll go to Analyze, Text Explorer, and then we'll have to select a text column. In our data table, I have negative reviews and positive reviews. Let's start with one of them. Let's start with the positive review. Put there as a text column. And once I have my text column, JMP will recognize that there's text in here. I can do some text analysis. If I were to put a numeric column, it would stop me, saying that I can't really work with that. So what's nice about this Text Explorer, it's available for a lot of different languages. So of course, my default is English because I'm in the United States. That's my display language, what I'm using right now. But if you have documents in different languages, again, this will work seamlessly. The very first thing to decide when you're using this platform is how many words per phrase that you want to utilize. And if you've done this type of work in the past, whether using different programming languages, you will have to decide you want to use 2-word phrases, 3-word phrases, 4 or 5-word phrases. But here in JMP, you can specify what's your maximum words per phrase. So this will include all the way from 1, 2, 3, and in this case 4. It's selected in my case as the default maximum words per phrase. And of course, you can make this as long or as small as possible. And maximum number of phrases. So this is basically, in this case, I'm saying I want to be able to work with top 5,000 phrases, the top 5,000 most occurring phrases. And the most important one here is minimum characters per word. How many characters per word that you want to use to include in your analysis? I mean, by default, it's set to 1. But in generally, when I do this type of work, I would set this to 4, so that I will basically avoid most abbreviations. I will avoid the words like a and the and there and but, those type of words as well. And again, maximum characters per word. How long of a word do I want to use on my analysis? The next 2 things to decide: do you want to do stemming in your analysis, which I described earlier? Stemming referring to, do we want to use just the root words, or we want to use a full word on our analysis? And for tokenizing, by default, it uses basic regular expression, but of course you can either customize it or you can just stick to basic words, and this gives you an option to treat numbers as words as well. So once I set this up, all I have to do is click OK. And what this will do is, in my first report, I get a list of all the words that are used, mostly used. So in this case, the word location showed up 372 times. The word phrase great location showed up 50 times. Good location showed up 34 times. So you notice here is that I didn't have to specify 2-word phrases or 3-word phrases. They're all included. Even 4-word phrases are included on my list of phrases. If you like to look at the data in a tabular format, this is basically, this is very helpful. But there's also, if you go to a red triangle, There are display options. Most people, when they first start looking at a text document, would like to see a word cloud. And if I click on that, you can see the word cloud of all the words that show up on my analysis. And once you're a word cloud, now you have options to customize it. Maybe you want to center this. Maybe you want to color it. Maybe you want to change the fonts. And I kind of like the look of this one. So kind of, in this case, I'm using Papyrus font. So it gives you a way to visualize all these tables. Since we want to use this text for analysis, and then it's out of your way. Want to use it for analysis, sometimes location itself, maybe someone using the word bad location or someone using the word good location, I want to be able to identify that, so I want to rely on the phrases. So what I will do is I will select some of these phrases, let's just say top 20, and I right-click on it, and I can add these phrases into my term list. So terms, by default, is only made up of words, but if I move these phrases, they will also be included on the term list. And you see here, good location showed up. And then I can see here, my word cloud is also updated as well. So it kind of gives me a way for flexibility on looking at the data and then work with it. Now, when I'm looking at the data, I also want to be able to maybe take out certain words. Maybe they're just showing up continuously, or I expect them to show up. For example, since I'm looking at hotels, the word hotel, I can treat it as a stop word, meaning that it exists there to provide context, but it doesn't really help if I want to identify important terms or things of that sort. And if I right-click on it, either on the table or on the word cloud, I can say, let's make this a stop word, and it will basically remove that from our list of words. And once I have the word cloud, I also can add other information into this graph. If I go to this triangle, I can put some arbitrary colors, or I can change the colors to be by certain column values. In this case, maybe I want to have these words colored by how their impact on the average score is. And if I click on OK, now you can see the ones contributing negatively and the ones contributing positively. And it looks like location is very important. What's also nice about this is, since you've been using JMP for a while, you are familiar with the fact that all data in JMP is dynamically linked. So if I want to see all the documents, meaning each row of information in my JMP document, if I use containing the word location, if I right-click once it's selected, I can say show text. Now I can see all the text that's using the word location. So I can look at each of these to see anything interesting, if I have a need to do that. And the use case for this might be that if you are looking at some warranty claims and certain words, certain part number, for example, showed up. And all you have to do is, once you build your word cloud, right-click, and then you'll get all the list of the warranty claims. Or this could be, in this case, we're looking at some European vacation. Like the next case study, I have another one about different wines. Ross did one of these presentations. He was looking at the Federal Reserve page book data. So as long as you have text, this gives you a way to drill down, dig deeper into text data as well. So that's kind of like the very first look into our analysis. And one more thing to notice here is that this table on top, it tells me I have 996 cases, meaning that 996 rows in my data set, and I have 1,785 terms that I am looking at. If I go to red triangle, so we talked about the display options that we kind of like looked at the term list, phrase list, and we showed the word cloud. There are some built-in stop words, but as you saw, if I right-click and I can add to that list of stop words. And if you want to modify this, or if you have maybe some organizational stop words that that's used over and over again. It doesn't contribute to the context, but it's there for, it doesn't contribute to analysis, but it's there for context. You can always add that as well. So you can modify your stop words if you have certain stop words that are relevant to your business. And similarly, so this is what the stop words I was talking about. I can manage phrases and stem exceptions as well. Now, so the very first box in the red triangle refers to visualization or displaying the data. And the second box is, what is it that we are doing with the text data that we have calculated, right? Well, we did some analysis. The latent class analysis, latent semantic analysis, these two topics are there to help us. Looking at this text, let's see if we can identify some existing topics. So looking at this data, we want JMP to look at the data and tell us, okay, there are 5 different topics here. And of course, we can assign what those topics' name might be. And we'll come back to this in a second. But what I want to point out here is that term selection, it's a very first tool to look at if you want to see which one of those words are relevant to a quantifiable number that's on your data set. So in this case, we're going to see which words are more relevant to the positive rating, to the rating of basically this hotel that they're looking at. And then we can use those words later to build a model from that. And the sentiment analysis is looking at text. In this case, each row of data is a text. We want to understand what kind of sentiment is contained in that text. So that's also built in. By reading the text, we want to see, okay, what's the sentiment here? It's helpful for consumer research. And we have an example data set if any of you are interested, and they're looking at the potato chips and they're looking at people's reviews of the potato chips, and then basically help to design what the next flavor will be in their potato chips. And we had customers and they are making beer, and of course they have tasting, and they're taking information from people's comments to help on their next taste that they want to build. And the document term metrics I mentioned earlier is that when we have this data, we want to convert that to just numbers. And I can do that by clicking on the Save Document Term Matrix. It's going to ask me how many terms that I want to save and what's my minimum term frequency. If you recall, let me move this to the side here. I need to cancel this for a second. So each of these terms, if I go to red triangle, Save Document Term Matrix, you notice here that I had 1,785 terms. How many of those that I want to save? So what this will do is, depending on how I want to save it, it's going to create a new column for each of that particular word or phrase, each of the term. And then it will put a markers if this particular term exists or not. And then the next thing I want to identify is minimum term frequency, how many times each of these terms showed up. In this case, location showed up 239 times. That's probably going to be created as a new column. But if it showed up less than 10 times, it's probably not going to. So let's do this for now. Let's say we want it to be 200. It should save only 3 or 4 columns for us. And for the weighting, if you're using this for exploration, I think the binary will be the good way to approach, saying basically this is going to assign 1 or 0, see if the particular word exists or not. But later, if you want to do it use it for analysis, then the document term frequency will probably be more helpful, because you don't really know if that particular word will show up or not in the next set of text. But if you use as a frequency, basically what's the frequency of that word being used compared to the rest of the document, meaning each row of information here. So if I were to go say okay and go back to my data table, and I should see at the very end three different columns, staff, room, and location. Those are the ones that more than 200 words. So that's how the document term matrix work, and now I can use this to build models. Close this one as well. Please, if you have any questions, put in the QA, and once we're done with the presentation, we'll address those as well. So that was the document term matrix. And so I mentioned that the term selection is extremely helpful, but before we go to that one, in this case, I'm assuming there's only one column of text. And you've been using JMP for a while. All the functionality of JMP, in each of the JMP reports, like the data filters or whether that be column switchers, they're available in Text Explorer as well. And for example, if I were to go to Red Triangle and go to redo and select column switcher, what I want to do is I want to switch positive review with negative review and positive review. Now I have a selector, and I can see the document matrix for positive, negative reviews. And of course, here now I can say, okay, negative is definitely going to be a stop word. It's not going to contribute to anything. And then so for negative reviews, room was important. And the second one's probably breakfast. For the positive review, again, staff and location are the most important one. Of course, breakfast and room come in third or fourth as well. So you can use column switcher, and you can also use local data filters. So if I were to remove column switcher and go to Red Triangle, turn on my data filter, and let's say I want to filter this by country, for United Kingdom, for Spain, you can see for each country what were the most important qualifiers in the text. So it kind of gives you a quick way to go through a lot of text at once and then get the relevant information for your analysis. I'll remove this one. Let me clear first. Remove this as well. So I mentioned term selection. This is probably going to be one of the most important ones that you use, mostly used one. So if I click on term selection, it's going to ask me, what is my response column? So let's say my response column is my average score. And now it's going to ask me, well, what is your target level? I want, of course, my average score to be as high as possible. And the model settings, so it's going to use generalized regression on the background. All I have to do is click on run, and it's going to select which words are most helpful to a particular term selection. So predicted 7.781, but actually it was 8.5. So in this case, depending on how relevant this model will be, it kind of gives you a way to identify or help out what is the right model, which words are more helpful on your term selection. Well, there are different ways of getting there. We'll talk about this. Just wanted to show you that this is available to you, and then you can save your prediction formulas, document scores, and things of that sort. I just want to be conscious of the time to make sure that I can show you most of the relevant things. And if I go to Red Triangle and go to sentiment analysis, what this will do is it's going to look at each of the documents, and from that, it's going to use built-in negation terms, intensifier terms, and sentiment terms. And each of those terms are assigned score. And as you can see here, you can change these scores as it's relevant to your business needs. And then it's going to basically all of these scores, average sentiment was 62. Positive sentiment average was 63, and negative average sentiment was 58. And you can see which words that show up in each of your documents and how much they contribute to the sentiment in the particular text that we are reading. And of course, you can add your own sentiment words, or you can change these qualifiers. For example, the word great, I want this to be or easy, but I can change these values to be, instead of very friendly, to being 90 or 95, I can change it to be 200, whatever that might be. I can make all those changes if I want to. And it can, of course, if I go to red triangle and I can save my sentiment scores in the data table, save document scores. So this will create a new column on my, let's just do that. If I go back to my data table, now you can see overall sentiment for each of those documents are listed. I mentioned earlier that we could use, for example, the column switcher. If I do that again, go back to redo column switcher, and I want to switch between positive and negative reviews. So I want to select negative reviews or positive reviews. Click on OK. Now if I go back to negative, and you can see all the scores are updated to be negative scores. So sometimes they will miss, for example, nothing to dislike. It's a neutral sentiment, but it will assign it to be negative score because dislike is itself set to be the negative word. But as you look at the data by looking at your business, you can customize it to be what the right way of what the right sentiment terms will be. So column switchers are available, local data filters are available. And finally, what I want to show you is we can use this text of the full document, full corpus that we're looking at, a number of terms, frequency. Let's leave it as it is, leave everything as default, and click on OK. From that, so it will take each of those words, and by default, it's selected 151 terms. It will build principal components. And since there will be a more of a sparse matrix, it will do singular value decomposition. And if I go to this red triangle, I can build topics. How many topics do I want? Let's just limit it to 3 topics. From that, it says, okay, there are 3 different topics that you ask for. And the first topic uses these particular terms. Second topic uses these particular words. And third topic uses these particular words. And you can always change the topic labels. Rename the topics. For example, topic 1 is something to do with the accessibility. Topic 2, something to do with the, feeling. Let's just make this up. And the third, maybe it's utilities. So by looking at the words, you can decide what each of these topics refer to. And since like I mentioned in the beginning, we're not talking about natural language understanding. This is going to be up to us to decide what these topic names are. And if I go to red triangle and I can build a scatter plot matrix, I can save these topic factors into my data table and work with them in detail. And what I will do now, just go do one more thing. I'll go to this red triangle and save document term matrix just for simplicity. And instead of 151, let's say I want to say 25. Okay. And I'll just basically demonstrate how we would use that. So if I go to my data table, analyze, for example, I want to create some embeddings. And I'll select my document term matrix and click on OK. And this will create embeddings from my data. And then you can see most of my data is basically grouped in one location. And there are some outliers. Maybe I want to see what these outlier points are. Selected on my data table. I'm selected on my graph. Go to my rows. Go to my tables, subset. And these are the ones selected. 50 data points, and these are the reviews mentioned in the particular reviews that I selected. If I want to look at these ones, again, go to my tables, subset, and there are 35 of them, and those are basically what's mentioned in those particular reviews. So take your data into visual format and then decide what to do with it and what type of analyses you can do. So that was like one example. And of course, you can do a lot more. If I were to go to, say, for example, analyze, and I want to do predictor screening, and I want my response to be my average score, and take my document term matrix as the factors, and click on OK, and say, okay, room, vary, and rooms, these are the ones contribute most to my result of average score. So the built-in user word, those are the ones that are derived from the dictionary. I mean, if you look at any dictionary, all these words will show up as built-in stop words. But if I want to add a new stop word, for example, a room, I want that to be a stop word, I can add that. So this will be user-defined stop words.
As you mentioned, so the user-defined stop word, that is now under your user. So when you log on to, say, Mac or Windows, now your user has the stop word room associated with it. So every time you launch Jump, room is going to be a default stop word. I believe Jump writes a separate file to your user profile in, all of the Jump files that it draws from. Column, it actually saves the stop words as essentially a column property. So now anytime you launch Text Explorer on this column of text, any stop word in the column list will automatically be applied. Especially if you're collaborating with folks and you're sharing data sets back and forth and you want to make sure that the stop words are always applied, I recommend using the column role here, because if somebody launches Text Explorer anew instead of, say, from a data table script, you know that they are still using the stop word list that you were, because it's associated, again, with the column itself. So then local, that's just local to the analysis. And then local exceptions is where you can basically declare an exception to the built-in list. So if you were to put and in local exceptions, and is essentially removed from the stop word list for the purposes of just this one analysis.
If you can export these stop words or import them from an existing list as well. But again, what I would do is I would encourage people to use the help button. That will take us to documentation, and it will walk you through how to use each of those options as well. And we use these options most of the time, but there are close to 20,000 different options in Jump, so we may not know. Or if you've been using for a while, you may use a certain portion, but help is direct link to documentation, and it will walk you through examples as well.
We have two more questions that are pretty closely related, so I'll try to phrase them as one. It all has to do with the weighting that you use, the document term matrix. We saw an example where you exported it using binary weighting. So that's just a 1 if a term appeared, a 0 if it didn't. But we see other ones under there as well. So you can use frequency, ternary, log frequency, TF-IDF, which stands for term frequency, inverse document frequency. And so I think there are just some general questions around when one might want to use one of these weightings versus the other.
So I mentioned the binary is extremely helpful if you're doing exploratory analysis. So that's just to identify if the word is there or not. If it's there, so it's 1. If it's not there, it's 0. Ternary refers to, and if you have a robot, it's going to kind of give you information about it too. If the word doesn't exist, it's going to assign 0. If it exists once, it's going to assign 1. If it's more than 1, then it's going to assign 2. And the frequency is going to be basically how many times this particular word occurs in that document. So if I say there's nothing to dislike, and then there is going to say, okay, happens once, nothing happens once, dislike happens once. And the log frequency is log of the frequency number, log 10, 1 plus x. And the IDF is basically taking the frequency in document and using so it's going to, like I say, in this particular sentence, this term occurred twice. But across my full corpus that I'm looking at, my full data table occurs 200 times. So 2 over 200, simplistically, it's like 1% of this particular term occurs 1% of the time. Again, that's what each of these mean.
I'm curious what you might think as well about why you might choose one of these over another, depending on your analysis goal, or depending on maybe the nature of the data itself.
If I'm doing exploration, if certain words showed up or not, again, binary is there to help me with that. If I'm going to use this to maybe apply to another set of text, and then maybe I'm building a model, then I would probably go with the document frequency term frequency inverse document frequency. So in that case, the frequency of the term appearing is going to be applicable because I'm applying this to another set of documents, another set of text in the same context. The frequencies will probably be more applicable than if the particular word occurs or not.